Greetings to all the judges. As a first year student, today I am presenting my project in International Women Empowerment Summit happening at our campus. My project title is Wireless Charging of Smartphone. So first, this is the entire project diagram with all the results. So in our project, the main core component is the primary winding and secondary winding. We can call it as the primary coil and secondary coil. Now, wireless chargers contains a magnetic pad on which a transmitter coil is placed, as you are able to see on the screen. Now, in order to obtain high frequency condition, we place the capacitors in parallel with the inductor or the winding in order to obtain the resonant frequency or high frequency condition. What is exactly the circuit? The magnetic pad is having the transmitter coil, which is purely inductive in nature. This magnetic pad is connected to the high frequency source. That means AC supply, what we are getting in our house, which is the charging slot. The charging slot is connected to the high frequency source and then to the magnetic pad. So the frequency which we do get in the charging slot is 50 Hertz. With the 50 Hertz, we cannot confirm the charging. We cannot confirm the charging, or we cannot assure the charging will be done within fraction of seconds or within short period of time. So low frequency, 50 Hertz should be increased to the high frequency using the resonant frequency circuit. So we do obtain high frequency 30 megahertz or 3 megahertz. This frequency is applied to the magnetic pad and to the transmitter coil. Now, according to Faraday's law of electromagnetic induction, huge magnetic energy is developed across the primary, which will link with the secondary winding. Now, secondary winding. So, in order to charge a smartphone, we are bringing the smartphone towards the primary winding. It is placed very close to the or close proximity to the primary winding. Both are not connected. So, from the Faraday's law, due to the mutual induction, magnetic energy from primary winding links with the secondary winding. As a result, current flows through the secondary winding. Now, the same current flows through the receiver circuit and the rectifier circuit, which converts AC to DC. So now, what exactly the operation? So let us consider a smartphone. In the regular smartphone, we have to open that smartphone. We have to place the receiver circuit, rectifier circuit. This is the magnetic pad, what we have mentioned earlier just now. Now you can see the entire working of the project is explained here. It works on the principle of mutual induction similar to the transformer. Yes. So this is the project diagram. So inside the every smartphone, we have to place the rectifier and receiver circuit. Now we are running this particular project. That means using the MATLAB software, I've developed this circuit. Now I'm going to test the results, whether the phone is able to charge or not, and we are able to transfer the magnetic energy from primary to secondary or not. So here I'm going to set the simulation time. You can see on the screen, simulation time for 10 seconds. Now you are turning on the project now. So let us wait for the result. Yes, this is a smartphone. Now you got the result. That means these two waveforms indicates that energy or magnetic energy, yes, magnetic energy will link from primary to secondary winding. So this is what the result of the graph.